with our project of how the Earth moves, and our last group is Lakush.
Hello everyone. So our topic will be the time, and in our team, my name is Love, and this is Luis, Sarah, and Ian. And we will start with Sarah first. Go ahead, Sarah.
Hi guys, I'm gonna be talking about what time is and just what it is because it's such a large concept. And Aristotle once said 2,500 years ago that time is one of the most unknown things. Currently still is. Time can be used as a time oh, I was doing that, or it can be used as a year, but in no matter scenario. So today we're going to talk a lot about entropy and the arrow of time. When we think of time, think of consistently an arrow that goes straight forward, only going straight forward. That is the arrow of time. You can't go back because that's just how it is. When the Big Bang happened, then when the Big Bang happened, the matter on the universe started expanding more and more, causing more entropy. When that happened, entropy is what you can differentiate the year 2018 from the year 1 billion, because as Earth keeps moving, constantly changing, that's how you differentiate when time happens. Sometimes I like to think of it as it's time. When you think of time, you think of a clock or a physical image that represents time. But is time physically there? I would like for you guys to keep that in your mind.
Hello guys, my name is Ian, and I'll be presenting time zone for you guys. So today, do you ever wonder when you travel, the reason why times change? So I'm going to explain that to you guys. Time zone is a region where we use the same standard time. And for example, I'm going to show you guys, this is where prime meridian comes. It's over here. It goes in between from Africa, Europe, and it touches a little bit of North America, stuff like that. And that's what separate the East Hemisphere and West Hemisphere. So for example, when the sun is directed over here, what it basically does, that's the reason why we have more daylight saving during the 24 hours, and it projects more sunlight towards the equator. That's why we have summer during June. And whenever the Earth rotates to the East Hemisphere, the sun directs to Africa and Asia, and that's why they have their summertime during around December right there. However, in between these two latitudes, there's 15 degrees in each and every latitude. So the reason why time changes, so the Earth will move like this, it's never straight. So it's like an axle, it's 23.5 degrees, and it moves around the sun. So when it does that, the sun will counterclockwise. And during that time, so if it goes this way, counterclockwise, it adds each hour. That's the reason why it changes. But if you go the other way, counterclockwise, you lose time 1 hour. So each time you go from America to Asia, each latitude, it adds an hour, an hour, an hour. So, yeah. Next one.
Hi guys, I'm going to talk about seasons, and right here I have spring, summer, autumn, and winter, like this year of 2020. These are the start dates of each season. So as you know, the Earth rotates counterclockwise from west to east. It takes 23 hours, 56 minutes, and 4 seconds, like Diana said. Once you round it up, it's 24 hours. So it takes 8,760 hours for the Earth to do one complete orbit around the sun. Spring. So spring has 89 days. which equals 2,136 hours or 5,340 minutes. Summer has 92 days, which equals 2,208 hours or 5,520 minutes, which, you know, it sucks. Summer's nice, a little bit of a time. Autumn, which is fall, has 91 days, which equals 2,160 hours or 5,460 minutes. And finally, winter. Winter has 90 days, which equals 2,160 hours or 5,400 minutes. Check this out. So halfway between July and January, during the September 23rd So during the halfway between July and January, during the September 23rd,
You got this. I believe in you.
at the moment. So this is why we received 12.
Good shot.
I'm gonna take the time to pass this to Love.
Hello everyone. So I'll be just covering just general facts about the side of time. So what it is, so it basically measures the rotation of our planet relative to the stars, and it allows astronomers to keep up with the time without worry. And also, it helps define the rotational period of other planets. Also, it also affects the constellation. And the thing is why it affects the constellation, because it's 4 minutes faster than the Earth day. So basically, so the stars usually appear in the sky 4 minutes earlier. And so that's why you will see certain type of constellation at Pacific time. And go ahead. And also, so before I get started, so I want to ask you a question like, how long does the Earth take to rotate once on the axis? So the usually answer is 24 hours, but it's actually 23 hours, 56 minutes, and 4 seconds. And that's the time that takes for the Earth to rotate about axis. For the distant stars appear positioned in the sky, and for the month, time for the moon to return to the same place against the stars, it takes about 27 days, 7 hours, 12 seconds. And the time of the sun.
Why are you reading from the screen? Stop that. Keep going. Oh no! All right.
Oh wait, hold on. So.
We got it done. Try that.
That's it.
Time? All right.